What do you think when you hear the word logarithm? Logarithms are not as confusing or intimidating as their name would suggest, and once you get to know them, you'll see that their bark is much bigger than their bite. Look at this expression, 3 to the second power equals 9. Pretty straightforward, right? So what if the 9 in this equation was unknown? How would we find it? The answer in this case is trivial. We square 3. 3 times 3 is 9. Now what if 3 was the unknown value? How would we find it? In other words, how would we solve for x? This one takes a little bit more thought. We want to get the x alone, but right now it's being squared. So to undo that, we take the square root of both sides. The square root cancels out the square power and leaves x. And we know the square root of 9 is 3. So x equals 3. Now what if the unknown value was the 2? How would we solve for x then? This is exactly where logarithms save the day. The relationship between the three numbers in this equation can be rewritten like this. This is a logarithm. Here, the 3 is what's called the base, and the 9 is the argument. You read this as x equals log base 3 of 9. The way to approach a logarithm is to think of it as a question. For example, in this case, you can think to yourself, what exponent of 3 will make 9? Or, 3 to what power is 9? And of course the answer is 2, because 3 to the second power is 9. Here's another example, log base 2 of 8. So, 2 to what power is 8? Well, 2 times 2 is 4, and 4 times 2 is 8. That's 3 2's we multiplied to get 8. So log base 2 of 8 is 3. Sometimes you see a logarithm with only an argument and no base. This is what's known as the common logarithm. Actually, this log does have a base, which is 10. We just don't write it because it's so common. Kind of like how we don't write the 2 on a square root symbol. So for this one, 10 times 10 is 100. That's 2 10's we multiplied to get 100, so the common log of 100 is 2. Other times you see a log that looks like this, ln of something. This is what's known as the natural logarithm. You can think of it as just a regular log, but the base is the natural constant e, which is about 2.718. I talk more about the importance of e and where it comes from in this video. I'll put a link in the description. Due to their nature, logarithms have some unique algebraic properties that often come in handy when solving equations. For example, if the argument of your logarithm has an exponent, you can move it to the front and multiply it by the whole log without changing the final value of the expression. Also, if you have a sum of two logs that have the same base, you can combine them into one single logarithm by multiplying the arguments. Likewise, if you have a difference of two logs, you can combine them by dividing the arguments. These properties make logarithms powerful and convenient algebraic tools. I hope this gave you a better understanding and a deeper appreciation for logarithms. If you enjoyed this video and want to see more like it, please like, subscribe, and hit the notification bell. Thank you for watching.